and we're going to be taking physics this time, and the topic we have today is electrostatics. Electrostatics is charges at rest. Electrostatics is charges at rest. This is charges or electric charges. Electric charges at rest. We notice that there are some charge or attraction that takes place unknowingly. For example, if you have your television or even your phone, the screen on your television or your phone, you see that it's able to attract dust. These are examples of electrostatics. We can have a ebonite rod. We can have some wood that during the harmattan season is able to spark or produce spark. These are charges at rest. There's a law that states that like charges repel, unlike charges attract. Like charges repel, while unlike charges attract. So, according to Coulomb's law, we state that the force of attraction between charges Q1 and Q2 is proportional to those two charges, is proportional to the product of those two charges, and inversely proportional to the square of their distance apart. According to Coulomb's law, Charles Coulomb law states that the force of attraction between two charges Q1 and Q2 is directly proportional to those two charges and inversely proportional to the square of their distance apart. Okay? That is Coulomb's law. Mathematically, it is written as F is directly proportional to Q1, Q2, and inversely proportional to 1 over R squared. Then this is joint variation. So we have a F is equals to 1 over 4 pi E naught R squared times Q1, Q2. So, by the time we multiply them, we have a F is equals to Q1, Q2 over 4 pi E naught R squared, where Q1 equals to charge Q1 and Q2 equals to charges, R equals to distance apart, pi equals to 3.142, E naught equals to permittivity of free space, which is given by E naught is equal to 8.85 times 10 raised power minus 12 coulomb square per Newton per meter square. Coulomb square per Newton per meter square. Okay? Other formulas associated with this electrostatics is, recall that F is equal to MA. F is equal to MA. That means F equals to F equals to Q1, Q2 over 4 pi E naught R squared. Which means that since F is equal to MA, you can say that MA equals to Q1, Q2 over 4 pi E naught R squared, where M equals to mass, A equals to acceleration. So, acceleration can be gotten by making a solid of formula where A is equals to Q1, Q2 over 4 pi E naught R squared M. But acceleration A is equals to change in velocity over time. Okay? If we are to get the velocity, that means we just say V over T. We are substituting for A, which is equals to Q1, Q2 over 4 pi E naught R squared M. So that means our V, which is velocity, equals to Q1, Q2 T over 4 pi E naught R squared M. That is the velocity or the speed of the charges. The speed of the charge. Other formula is below. But recall that 1 over 4 pi E naught equals to 1 over 4 times 3.140 times 8.85 times 10 raised by minus 12. That and 1 over 4 pi E naught equals to K, which means that K is equals to 8, 9, 8, 9, 9, 9, 9, 9, 9, which gives us K is equals to 8, 9 times 10 is power 9. 9 times 10 is power 9, which is Newton meter square per coulomb square. That is a unit. That is a unit. Okay? That is a unit. Knowing fully well that our V equals to Q1 Q2 T over 4 pi E naught R squared M. We can also write, since our 4 pi E naught, 1 over 4 pi E naught is K, it can be written as V equals to KQ1 Q2 T over R squared M. These are the formulas you should take notes of. Also, F is equals to, by following this rule, KQ1 Q2 over R squared. Now, we can calculate the distance. We want to calculate the distance of the charges. The distance of the charges is different from the separation. Separation is R, but the distance is the distance is the motion that the electron is able to cover, or the charge is able to cover. Okay? That means, since we have two charges, to calculate the distance, we have to recall the fourth equation of motion, which says that S is equal to V plus U T over 2. So 2S equals to, if U initial velocity is 0 or the final velocity is 0, then we can say that we are having Vt. Okay? So that means our S is equal to Vt over 2. So if, or we say our V is equals to 2S over T. 2S over T. That V is equals to KQ1 Q2 T over R squared M. So since our V is equal to 2S over T, we have a 2S over T equals to KQ1 Q2 T over R squared M. So S now becomes, S is equals to KQ1 Q2 T times T, we have a T squared over 2 R squared M. 2 R squared. So we can easily use this formula to solve questions. These formulas to solve questions. Okay? Other useful information under electrostatics can be seen in electric field intensity, electric field potential, electric field intensity, electric field potential, electric potential energy, electric potential energy, and so on and so forth. So we'll continue from there next time when we will meet.